Hello everyone, welcome to Flight Deck, and today we are going to derive one of the most important equations in aerodynamics, which is the lift equation, but not in the usual way. So we are going to use dimensional analysis, which is one of the three major approaches used in aerodynamics, alongside momentum theory and vortex theory. So this method doesn't rely on flow visualization or complex fluid mechanics. Instead, it uses pure dimensional reasoning. So moving on, the lift equation, this is the equation that we are going to prove today. L equals CL, coefficient of lift, into half rho v squared s. So L denotes lift, CL denotes coefficient of lift, rho denotes density, V denotes velocity, and S denotes surface area. So from experimental observations, scientists have found that the aerodynamic force acting on an aerofoil depends on several key variables. The variables are free stream velocity, air density, size of the object, speed of sound, and viscosity of the air. Apart from these variables, they have found that shape, attitude, and smoothness also contribute to the aerodynamic force acting on an aerofoil. The problem is we cannot easily quantify the shape, attitude, and smoothness. So what we are going to do is we are going to group them into a constant, and we are going to call it as K. So moving on, now we can take the aerodynamic force which is acting on the aerofoil is proportionately equal to K, which is shape, attitude, and smoothness times the velocity, density, wing area, speed of sound times viscosity. But now in the dimensional analysis, what we need to do is that we need to determine the written unknown powers, which are A, B, C, D, and E. So now we will convert everything into MLT dimensions. So as per the basics in physics, we know that velocity is the rate of change of displacement. So when we write velocity in dimensions, we can write it as L t minus 1. So what is acceleration? Acceleration is rate of change of velocity. So it can be written as L t minus 2. So what is force? As per the Newton's second law, force can be written as mass into acceleration. So dimensions for force will be m. For acceleration, dimensions will be minus 2, mlt minus 2. So that's why here we have written dimensions for force, the aerodynamic force, as mlt minus 2. So other dimensions are written as velocity is Lt minus 1. I have already briefed it here. So it's the same thing here. And then for density, this is ml minus 3. Area is L squared. Speed of sound is Lt minus 1. And then viscosity is ml minus 1 T minus 1. So these are all derived through their basic definitions. So as per the equation we took earlier, I will call it as equation 1. So equation 1, I am going to write it in dimensions. So force, I have already written it in above as mLt minus 2, and then we have the constant. The constant cannot be written in dimensions, so I am not going to use it in the dimension equation. And V, it will be Lt minus 1, and power A will be kept here, and then I have rho ml minus 3, and then surface area as L squared, speed of sound as Lt minus 1, and viscosity as ml minus 1 T minus 1. So here is the same equation I wrote earlier, same dimensional equation. And normally we all know that in a dimensional equation the left hand side should be equal to the right hand side. So which means dimensionally the indices should be equal. So I will solve right hand side and I will get the following equations for the basic dimensions time, mass and length. So for time, if the RHS equal LHS, then we can say left hand side is minus 2. And then if you solve the first, it is minus 1 into A, which is denoted here, and then there is no time dimension here, and then we have time dimension here, so it will be minus D. So we can get the minus D here, and then we have another minus E here, so we can write it here. So this will be the equation number I will get as A. And then again I will write for mass. So here the indice of mass is 1, therefore I write 1 here. And then for right hand side I will write B and E. So plus B plus E equals 1. So that will be my B equation. And then solving for length, again it will be 1, and then we have A, we have a minus 3B, and we have a plus 2C, and we have a D, and we have a minus E. So it is written here A minus 3B plus 2C plus D plus E equals 1. So that will be my C equation. So now I will solve these equations and I will try to get now I will substitute into the length equation and simplify. So now here I have rearranged equation A and I have rearranged equation B. So now I will substitute into the length equation, which is my equation C. So after substituting, I will write A as 2 minus D minus E, and then I will write B as 1 minus E, and I will simplify it, so I can cancel D to D, and after simplifying I will get C equals 1 minus E divided by 2. So that will be my basic equation for C. I will insert the values taken for A, B and C in the equation number 1, which I wrote earlier, and here I have inserted the values taken for A, B and C. So simplifying indices, I can get an equation like this, which is F equals K times V squared rho into S, and through the powers of D I can get A here, and I have a minus D here. So I will write A divided by V in the same brackets under the under the power D. So under the power E there is a V, and then there is a minus, rho minus, and then I have S minus, and I have mu minus. So writing all those under one power, I can write mu divided by V rho S to the power half. So that will be my simplified equation, which is rearranged under same powers. So dimensionally, you know that S to the power half can be written as S can be written as L squared. So you know, when we simplify this, it is equal to L. So now we can write the same equation like this. So why I did this, you will see next, because I want to get definitions to make them easy, to make them more simplified. So now simplifying the early equation, I have got this equation, which is F equals K times V squared rho times S into A divided by V times D to the power D, and times mu divided by V rho L to the power E. Now, as per the definition of Reynolds number, it is the ratio of inertial to viscous forces in fluid flow, indicating whether flow is laminar or turbulent. Now, but by that definition, we can get Reynolds number is equal to V rho L divided by mu, and Mach number is ratio of object speed to local speed of sound, indicating compressibility effects and flow regime. Basically, Mach number is the velocity of the object with respect to the speed of sound. Now, here the above equation, this equation I can write it again, and because it has A divided by V, I can write it as 1 over m, and the Reynolds number here there is a mu divided by V rho L, so I can write it is 1 over Reynolds number. So now I have come up with this equation. I'm going to rewrite the same written equation, but here I'm going to make a difference. I'm going to write 1 over m to the power d as m to the power minus d, and 1 over Reynolds number to the power e as Reynolds number to the power minus e. So we know that dynamic pressure can be written as half rho v squared s. We have the half rho v squared s here, but there is no half. So what I am going to do is, I am going to multiply the same equation by 2 and divide by 2. Okay, so this half rho v squared s is going to be the dynamic pressure. Now because I multiplied by 2, I have a 2k here. So I am going to introduce another constant for this, and I am going to name it as C. So C is equals to 2k, and therefore I can rewrite the equation as F equals C times half rho v squared s m to the power minus d and Reynolds number to the power minus e. So here the Mach number and Reynolds number are unknown exponential functions. Now let us assume that for an exact equation the Mach number and the Reynolds number are included in constant c. So my earlier equation is written here, which is F equals C times half rho v squared s times Mach number to the minus d and Reynolds number to the minus e. So since I assume that Mach number and Reynolds number are included in constant c, I will introduce c as Cl, and I will write it as Cl equals 2k, because it includes the earlier 2k constant, and Mach number and the Reynolds number. So C becomes a coefficient dependent on Mach number, Reynolds number, shape, attitude and smoothness. So the aerodynamic force that we assumed, we proved is lift. So therefore we can write the lift equation, which is L equals Cl times half rho v squared s. And similarly, if we deduce it for the drag, it will be the drag force equals coefficient of drag into half rho v squared s. And that is how we deduce the lift equation through the dimensional analysis. Thank you for listening to my explanation on the dimensional analysis to the lift equation. Hope to see you all again. Please subscribe and like if this was valuable to you. Thank you.